Hi, I am Yi-Hui Jo. I will be presenting our paper, Evaluating Self-Supervised Speech Models on the Taiwanese Hokkien Corpus, on behalf of my amazing co-authors, Kalvin Zhang, Meng-Ju, Winston O, Alice B, Carol Yang, Bryan Chang, Rong-Wei Bai, Boyan Ye, Jo-Peng Jiang, Iu-Tshiann, Winnie Zhang, Chenxuan, Noel Chen, and Jiatong. This is the outline for today's talk, and let's start with the introduction. So, Hokkien is a language spoken in the southern part of China, Taiwan, and Southeast Asia. There are multiple regional dialects and variations influenced by the linguistic and cultural diversity of its regions. And our focus of the study is Taiwanese Hokkien, or Tai, which is a unique variant of the Hokkien language spoken by 18 million Taiwanese people. And this language is currently facing a decline due to the language shift towards Mandarin in 1950 to 1980s. It is mutually unintelligible with Mandarin and has complex tone-sandy rules. Furthermore, Taiwanese Hokkien is not widely written, but can be, using hand characters or romanization. And here's an example of Taiwanese Hokkien written in hand characters, romanization, and its translation in English and Mandarin are also provided. Now that we have a basic understanding of the language, let's take a closer look at our curated dataset. We utilize Taiwanese soap operas on YouTube, which offer natural but noisy speech with gold Mandarin subtitles. We segmented each utterance using subtitle timestamps and manually corrected problematic ones, resulting in three subsets: train 10-minute set, depth set, and test set. Here's the dataset statistics. In total, we curated a 1.5-hour dataset with 2,600 utterances from 30 dramas. And because the dataset lacks Hokkien transcriptions, we annotated them in romanization. Specifically, we denote the base tone, which means that the ASR model needs to learn tone sandy, and we preserve dialectal variation, syllable contraction, and include particles. Cool. Moving on to our experiments. This is the model structure we used, which contains the front-end, encoder, and decoder. For front-end, we experiment with 12 different self-supervised learning representations, as well as the traditional F-bank feature. And as for encoder and decoder, we utilize a transformer-based model. Now let's look at the results. So the first line here shows the traditional F-bank feature, which does not yield a decent performance. And the 12 models here are different self-supervised learning representation, and among them, Hubbard models pre-trained on Mandarin gives us the best performance, with a 33.7% syllable error rate and a 22.7% character error rate, fine-tuned on our 1-hour training set. And this model is pre-trained on Mandarin, which is linguistically more aligned to Taiwanese Hokkien. And the best performing models are pre-trained on multiple languages. When we analyzed our best model, we found that it confuses phonetically similar sounds, often predicts the wrong tone due to tone sandy, and suffers from poor audio quality, which is sometimes hard to understand even for humans. In conclusion, we contribute a 1.5-hour dataset of Taiwanese Hokkien for ML Superb Hidden Set. Our experiments showed the importance of quality and linguistic alignment between pre-training data and target data. For future work, we encourage researchers interested in Taiwanese ASR to focus on improving errors related to phonetic similarities and Tongsandy. Additionally, Taiwanese to Mandarin translation is another exciting research topic. That's it for our paper. Thank you so much for your attention.